Well, Apple just made trusted hardware sexy and cool. You know, these PC and Mac commercials, wow, they're funny. I have people coming up to me that I haven't talked to in years, and like, you're a Mac user, right? Yeah. Have you seen? Yes, I've seen the commercials. They're funny, they're cute. Yes, it's little guys in the box, and my parts are over there, ha ha ha, and they think it's great. You know, they're gonna. I mean, they're not gonna dominate the market, but they're clearly gonna go from 3% to 6% or something of the market. I mean, this is gonna be a big deal. You know, this push to Intel was a fantastic freaking brainstorm that probably anybody could have told them was a good idea, but Steve Jobs crafted it into like it was divine, you know, intervention for him. Virgin Mary came down and told me, hey, you should go to Intel. I go, oh, go to Intel. Enter the MacBook Pro. So Apple, when they switched to Intel, clearly this is a threat to their position in the market, right? They went back and forth in this, you can clone us, you can't clone us, you can clone us, you can't clone us crap. And they haven't been able to, you know, sell a clone Mac for, what, 6 years now, 7 years? It's been a while, 99, I guess they got rid of the whole clone market. And so they've got certainly a captive base when it comes to selling hardware and running Apple software on it. Well, when you go to an x86 platform, you're at risk of losing that. So Apple wanted to find, I mean, I'm saying this in speculation. I do not have inside information, I don't work for Apple, but it appears that they wanted to find the particular bits about what makes Macs, you know, user-friendly and useful, that were going to keep them dominating the hardware market and protect people from running it on a general purpose x86. And the big thing that they had during this migration is this emulator called Rosetta, which does real-time rewriting of PowerPC opcodes, x86 opcodes. And, well, that's pretty cool. It's pretty damn cool. I was originally going to run this on an x86 PowerBook. I'm currently running it on a PowerPC, though, due to various reasons. But, I mean, I could run Microsoft Office as fast or faster as I ran it on my G4 PowerBook. You know, it's pretty cool. And Apple knew this, so they protect it with a TPM. So when Rosetta instantiates itself, it goes and looks for this trusted chip that's on the motherboard. It says, hey, are you there? The chip says, yeah, I'm here. Oh, okay, then I'll start then. And it goes off and it starts. This Russian hacker Maxis repeatedly released bypasses for this, okay? You could then boot, I mean, you could always boot and run OS X on an x86 box as long as you didn't care about this PowerPC thing or a few other odds and ends that hooked into the TPM. Maxis just chopped it all off at the knees, or as Mike Wynn would say, kicked it in the nuts, and it worked. Apple came after him. He changed domains half a dozen times. I'm not sure if I tried to find the Maxis patches a few weeks ago, and I actually couldn't track them down anymore. You know, so Apple, don't underestimate Apple lawyers. Apple lawyers and Microsoft lawyers could have like a cage match, just throwing subpoenas at each other and everything. It would actually be pretty good. I mean, I think it would be pretty evenly matched. So anyway, then here's my PowerPoint diagram in case you couldn't get from my sound, you know, track what the hell's going on. Backing up a step. So I threw out this acronym, TPM, and I didn't explain it, which is big no-no, right? So let's back up and talk about trusted computing. So this thing called the Trusted Computing Group, which used to be the Trusted Computing Platform Alliance, TCPA. It's an industry group, right? You pay the money and you can join, that set standards of trusted computing systems and architectures. Pretty broad group of folks bought into it. Most of the big boys, Intel, AMD, Microsoft, all these people. They used to be focused solely on the development of this trusted module, a TPM, that ran on, you just soldered on the motherboard, and it did its thing. Now it's got a broader scope. They're looking at infrastructure, how this impacts infrastructure, mobile devices, PC clients, servers, software stack. It's pretty important. If you're going to use a module, it's kind of hard, turns out, to access a device directly all the time and like write hex codes to it and off of it and not have any abstractions. So they've actually got a pretty robust standard for software stacks. Trusted network connector, which I'll get into in a minute, and other odds and ends. In general, what they're trying to do is say, hey, when we have this capability that we've all been dreaming about for 45 years, what can we really do with it, okay? Well, at first blush, people think, you know, well, clearly you're going to violate my privacy because everyone who's not at this conference wants to violate our privacy. Don't you know? It's only paranoia, or it's not paranoia if they're actually out to get you, right? Jeez. So everybody gets all wrapped around the axle about, you know, holy crap, like this is gonna be the worst thing ever. Okay, so first of all, let's talk about what they have to say about privacy. Now, granted, this is their own Kool-Aid, so take this with a grain of salt. Excuse me. They basically say, hey, the owner can opt in to how this thing is used. Okay, they can choose, how they want to use it, how they want to, information gets exposed, how the interaction with software happens. Now, let's be real clear on one term here, the owner, okay? The owner of your personal laptop generally is you as an individual. The owner of your enterprise laptop that you got from your place of work, well, that's not yours. You should have no expectation of any privacy on your enterprise devices anyway, right? Just because you tunnel out over SSH all your porn doesn't make it okay, okay? Just little FYI. Someone finally shut the door. I guess either I was too loud or they were too loud. It's not like you download a piece of software. Download iTunes Music, or iPods, whatever the hell, iTunes. There, I figured it out, wrestled that sentence to the ground. You download iTunes. It's not like iTunes takes ownership of your TPM and says, mine, and hides all it from you, and there's this quiet cone of silence where it all executes at. No, actually, as the owner of the device, you can control what happens. You can make the keys that it accesses in there. You can export them. You can put them on another machine. You can do all this kind of stuff. Note, we're in a time when backing things up becomes really important. Apple, when you buy a bunch of music, they're always saying, hey, don't forget, you've just spent hundreds of dollars here. Back up your music, because if your hard drives crash, you're kind of screwed. It's going to become even worse. Like you're actually going to have Mom, Pop, Kettle worried about backing up the cryptographic keys that are stored in the TPM. That's going to be strange, and that's going to be some user interface issues that need to be tackled. I'm all over the road today. Whatever I'm on is really kicking in. Chips are manufactured by a variety of vendors. The TPM on its own, like I said, it doesn't do anything. It sits there. Okay? You boot it today. It's in, anyone have like a IBM T43 or an IBM T50 series? Got one guy down there. They've got TPMs built into them, but not necessarily by default does it do anything unless you have software that accesses it. So I know IBM's got some capability to actually modify what's on there. Apple, it turns out, doesn't. By default, there's no way to interface with a TPM, which is kind of a pain in the butt, which is something that we're going to show here in a bit, actually, how you can do it. So higher level systems, such as boot managers, operating systems, applications, have to make use of this thing to be of any good. So the evil bit isn't set until the applications try to access it, okay? Just to be clear, it's not evil, not from the get-go. Here's what's inside the chip. You got your standard issue I/O bus, you got some RAM to do stuff in. You got this thing called the PCR, your platform configuration registers, and this is particular information about your system that's unique to your system. The manufacturer, serial numbers, types of peripherals on the main board, types of peripherals hooked up to the device in general. What these registers ultimately describe is a unique system that's yours, okay? So these PCRs end up being used by other functionality to say, hey, if I want to bind something specifically to this host, I'm going to use some of the information in the PCR to be able to bind it there. Or if I want to say something about what's on this host or the integrity of this host, I'm going to reference all this information so somebody knows, absolutely, this is the host that I'm talking about, okay? That's not something as a user you can go in and modify. This is not like you can delete it, you can reset it. But you can't just load in arbitrary information into this thing and say, oh, here's, I want a hash that pops out of this to be hex 0535, whatever. No, it doesn't work like that. You also have this identity, attestation identity key. So part of the idea with the TPM is that you can tell other devices, things about yourself. If you're okay, if the chip's okay, if the operating system's okay, all these kinds of things. So there's a key store there, and that's, again, unique to your TPM that signs all those messages. There's program code, which is basically custom stuff that the manufacturer can put in there to do some of this heavy lifting with respect to attestation, things of that nature. There's a RNG, note, not PRNG. This is actually a hardware random number generator. Woohoo! We don't have to have these esoteric arguments of how good random is. These vendors all have certified RNGs or should have certified RNGs on their TPM. There's a SHA-1 engine. Yeah, we can get into arguments about how good SHA-1 is, but it's a SHA-1 engine. Key generation engine. Here's the opt-in thing. I temporarily deactivated it. And then there's this execution engine that's basically general purpose kind of CPU. It's where stuff gets done. So when you want to interact with the TPM, for those that have done smart card work, it's very similar to how you interact with a smart card. This is not something that's sitting on the side churning on its own. You have to ask it a question. Sorry. Test. This is cute. That's where I do a little. You have to ask it a question in order to get an answer back from it. So in this case, the application will make a library or socket call to the software stack. The software stack then talks to the low-level driver that's chip specific. The driver will send a datagram, a hex datagram, and then the TPM does its thing, kicks the datagram back up, and then it obviously pops back up through the food chain. So the datagram on the left, hopefully. Well, anyway, the one datagram that you saw was the, if you can remember, bonus points, anyone that can remember the 12 hex digits that were there. That was the startup datagram, which is a particularly thorny one for me because I spent a lot of time trying to get the TPM on the MacBook Pro to work right, and it kept just flaking out saying, hey, I've been deactivated, and much like our VGA screens. And I couldn't figure out why, and it was because when the chip comes online, the operating system will send an init, which basically turns it on, but never actually started it. And so all the other codes he sent to the thing were like, no, just responded with, I don't know what the hell you're trying to do. And then one day I found a little esoteric statement that said, oh, you have to start the damn thing. And it literally is, it's one of those things, like it's just 12 hex digits. You send it, boop, and it comes online. Real quick here, the first line is basically the type of message it is. Second line is the size. Third and fourth line are just these, basically that's the arguments that you're sending. The 99 is a startup, and 01 is a type of startup. In this case, starting fresh, popping fresh, just going from the get-go. There are a lot of commands the TPM understands. The document is from the TCG that describes this is a couple hundred pages long with all the different commands that it can understand. I've tried to break them down into a high level and apparently running into each other breakdown. There's the admin idea, state saving, self-test. That you can do these full self-tests where if it doesn't test properly, it shuts itself back down. You can take ownership, you can clear all the chip, just basically say, oh, starting over, sorry, screwed it up. Key management, you can export and import keys. There are two types of keys, migratable and non-migratable. Non-migratable keys, as you might guess, you can't take off the chip. So those are the ones that if something's encrypted with that and your chip goes bye-bye for whatever reason, or the computer goes bye-bye, that data is gone, okay? Real good to know if a key is migratable or not migratable. Crypto, you can bind data. They had to invent new terms, apparently. Bind means you're encrypting it, usually using a non-exportable key. So this is where you're encrypting a chunk of data, and now it's bound to that key that's in the box, in the TPM, and you can't do anything about it. You can sign stuff. You can seal stuff. Seal's really exciting, because even if you used a migratable key when you were binding it, well, now you're binding it not just with that, but with the PCR data. So now it's specifically tied to your hardware. That's really fun stuff. Sealed sign, so now we've got encrypted sign data that's bound to your device, hashing, and numbered RNG capability. Session management, there is an understanding of sessions. It's, again, kind of like smart cards have channels. You can, create sessions, load context. There's transport management, hoo-ha you can do. And then in general, you have the ability, some of them are field upgradable. You can delegate some authority. You can, I'm not sure dump NVRAM, but you can certainly clear the hell out of it.